up as shown by arrow A, enter the desired number of significant digits for both the x and y coordinates. Usually, 10 significant digits should give precise numbers of data set. You should see the dataset values change according to the newly set significant digit value next to arrow B. If you want to delete any points for some reason, such as the wrong point was selected or it does not seem precise enough, then it can be deleted by selecting it from the data set as highlighted in the example over here, and then clicking the Delete Selected Data option. The coordinate will also be highlighted in green on the image where the point is located as shown by arrow A. This allows you to make sure that you have selected the correct point. To export and save the data as a text file, select the symbol that looks like a square disk as pointed by arrow B, and then a window will pop up that allows you to name and save the text file where you want it to be. Make sure to save the file with a standard naming convention. Usually, naming the file as same as the figure file makes it easier for you to match the image file with the text file and helps you navigate through the bunch of files later on. There are some special cases in terms of the types of graphs you are trying to digitize. In the graph shown over here, there is a curve. In this case, the trace curve function can be used by selecting it in the mode drop-down menu after entering in the axis values based on the scale provided in the graph. The trace function will allow to select a few points along the curve from start to finish, which will plot points along the curved line. Once the tracing is done, click Accept Traced Line where arrow B is pointing. If the graph does not have x-axis on a continuum and is categorical, as shown here in the middle image, then only worry about inputting the y-axis coordinates appropriately. For the x, simply put 1 or any other number you want because it doesn't matter. Once the dataset is exported as a text file, you can go back to it and change the x values to a categorical value or an appropriate name, and leave the y coordinates as it is. In the middle panel, all the points on the side of the blue bar are for the left atrium. And since we only want the atrial data, only select the circles on that side using the zoom view feature. The third scenario is when the axes don't intersect with each other, and so it becomes difficult to estimate both the x and y coordinates for their point. In this case, when the first axis point is chosen, select one on the x-axis and leave the y coordinate blank, and then select OK as shown by arrow C. This allows you to enter 4 separate coordinates independent of each other. Make sure that the second point that you select is also on the x-axis, and then the third and the fourth point will be on the y-axis. The program will guide you so that you know which coordinate to enter, x or y. An additional feature of this program is to use the Scan for Symbols option. This allows to automatically select for the symbols of interest if 2 different shapes are present. For example, in this graph, we are only interested in the control data for the left atrium, which is represented by circles. We can use the Select for Symbols feature to choose only the circles, which makes digitizing quicker than manually selecting each point. To do so, after selecting your axes, in the Mode drop-down menu, pick Scan for Symbols, which is indicated by arrow A here. Then, change the window size to match the size of the symbol of choice using the Zoom feature. In this example, the window size is 12, over here pointed by arrow B. Using the Zoom feature, choose the point on the graph that clearly shows that symbol. In the next step, you have to erase some of the extra pixels from the scanned symbol. The middle graphic over here shows the window that pops up that allows to remove some of the extra pixels. These are unwanted and can sometimes choose the wrong points. So make sure to clearly only keep the shape that represents the actual data that we are trying to select. In this case, a circle. Using a left mouse button, go over the unwanted pixels and then click OK. Now the symbols have all been marked by a green square in the middle of each. You can adjust the threshold for selecting the symbols in case some of them have not been marked by moving the slider and adjusting the threshold over here as shown by arrow C. Notice that in the example above, the circle in the legend where arrow D is pointing has also been selected. Make sure to delete that point and any other unnecessary points that have been marked by this feature. The Scan for Symbols feature is useful and reduces the time required to select all the data points, but it is only to be used if there are two different symbol shapes and you have to make sure to be careful to review the data set and remove any unnecessary points that may have been selected. Otherwise, it could alter the data. In conclusion, digitizing data makes data collection from scientific papers efficient and precise. The various useful functions of the scan software helps digitize data from different types of graphs with precision. The ion channel data can be used to incorporate electrophysiology of atrial cardiomyocytes into a mathematical whole heart mouse model to aid in finding therapies for heart conditions such as atrial fibrillation. I would like to thank NSERC, CIHR, Canary, Compute Canada, Victoria Hospital IT, and Western University Technology Services for supporting this project.